Welcome to The Explainer. So today we're going to completely shift your perspective on something you probably have sitting in your pantry right now. We usually think of chocolate as this simple, natural treat, right? Like it just magically hops from a tree straight into a candy wrapper. But the reality? Oh man, it is an absolute marvel of modern industrial engineering. We're going to bypass the whole romance of chocolate making today and really zero in on the incredible machinery, those precise thermal controls, and the massive automated systems that actually make the whole shebang possible. Okay, let's dive straight into this factory blueprint. We're going to track the entire system step by step. We'll start with sourcing the raw input, then move into automated cleaning, witness the thermal and mechanical transformation, explore the fluid dynamics, and finally wrap it up with precision molding and packaging. Part 1. Sourcing the raw input and supplying the factory pipeline. Let's look at exactly where the messy, organic reality of farming collides with our highly controlled modern industrial systems. So, looking at the supply chain flow, it tracks the physical journey of this raw material. It kicks off with workers carefully harvesting the ripe cacao pods right off the trees. They open them up, extract the raw beans, and collect them into these massive containers. And from there, it's a super fast transition. They load them right onto transport trucks that haul them straight from the dirt and the farm to unload directly onto the factory's massive receiving conveyors. And what's absolutely amazing here is that this whole thing operates as one continuous pipeline. It's an unbroken workflow where this raw, totally unrefined material moves without a single interruption from the fields directly to the humming factory entrance. Literally, the moment those transport truck engines cut off, the heavy conveyor motors take over. Moving to part 2, automated cleaning and preparation, or purifying the input. Now we've officially entered the first true mechanical stage on the factory floor, where we have to prep this raw agricultural material for some seriously heavy industrial processing. This sequence brilliantly illustrates the specific mechanical gauntlet our raw material has to survive. First, the beans move along relentless conveyor belts right into advanced air cleaning systems. They're meticulously washed, mechanically dried, and then pushed through sorting stations. This is where defective beans are physically removed, all under the strict supervision of factory workers. It is just an incredibly precise automated setup. And our source material really hits the nail on the head here, noting that before becoming chocolate, cacao beans are cleaned and prepared for transformation. That word, transformation, is key. This rigorous, mechanized prep is absolutely essential. I mean, if the input isn't completely pure, the heavy machinery in these next phases just cannot do its job properly. Which actually brings us to a major engineering hurdle. I want you to think about this for a second. How exactly does an industrial facility take a dry, solid, totally coarse seed and turn it into a smooth, flowing liquid? And crucially, how do they do it without just watering the whole thing down? Well, the physics involved here are absolutely fascinating. That takes us to part 3, thermal and mechanical transformation, the phase change. And frankly, this is the most brutal and intense stage of the entire manufacturing process. Looking at this factory manifest, just notice the sheer mechanical force being applied here. First up, we've got industrial thermal roasters blasting the beans with extreme heat, effectively cracking their shells. Next, they're fed straight into massive mechanical grinders. These grinders use extreme friction and intense pressure to literally shatter the solid bean. This forces its natural fats to melt, converting the whole thing into this dense, workable liquid state that the industry calls chocolate liquor. The stark comparison really highlights that phase change perfectly. On one side, you have the raw cacao bean. It's solid, coarse, highly irregular. But on the other side, you've got chocolate liquor. It's fluid, uniform, and completely workable by machines. It really goes to show the immense mechanical impact and raw thermal power required to break down a rigid organic structure into a fluid that can actually be pumped through an industrial factory line. Moving right along to part 4, fluid dynamics and refining, perfecting the formula. So with our material now in a completely liquid state, we're seriously scaling up the engineering complexity here to focus entirely on fluid dynamics. Now, let's define a term you absolutely need to know. Conching. This is a highly critical mechanical process, all supervised by factory workers, where massive machines just continuously fold, mix, and grind the fluid. It's this prolonged, fully automated stage designed to microscopically refine that chocolate liquor. That's actually what develops that incredibly smooth texture our palates always expect. Conching relies on a seriously advanced automated production system. I mean, we're talking about large-scale machines using steam and highly precise thermal regulation. Enclosed mixing motors are just relentlessly churning the liquid, while these complex automated piping systems direct the flow of this newly smooth, refined chocolate exactly where it needs to go next across the massive factory floor. And finally, part 5, precision molding and packaging, the final output. This is where those fluid dynamics give way to high-speed robotics and automated finalizing equipment. But actually, before this liquid can take its final shape, it has to clear one last crucial hurdle: tempering. This is an incredibly controlled, highly precise thermal process that stabilizes the liquid chocolate's molecular structure. Basically, without tempering, the chocolate wouldn't set properly, it wouldn't have that satisfying snap when you break a piece off, and all the fats would just separate. It is, top to bottom, pure thermal engineering. Checking out the finalization sequence, the newly tempered chocolate flows right into precise molds, then passes continuously through these automated cooling lines to completely solidify. From there, it undergoes some rigorous inspection by factory workers, just to ensure absolutely perfect uniformity. And once it's cleared, high-speed robotic packaging machines just seamlessly wrap the product, prepping the boxes for rapid global distribution. So this entire massive industrial pipeline, which, remember, literally started with workers pulling pods off trees in the dirt, culminates right here. As the source material points out, after all that careful inspection and robotic packaging, the finished boxes are loaded straight onto shipping trucks. You can almost picture the aerial view, right? Watching these trucks roll out of the factory, carrying what is now a perfectly uniform, heavily engineered product to people all around the world. As we wrap up this explainer, I really want to leave you with a final thought to chew on. We've seen the thermal roasters, the heavy-duty grinders, those massive conching motors, and the high-speed robotics. It's just an absolute triumph of industrial machinery. So honestly, the next time you snap a perfectly uniform chocolate bar, ask yourself, are you tasting the agriculture or the engineering? Thanks for diving into this with me today. I really hope this look into the heavy mechanics behind the magic has sparked your curiosity.